Okay, on our next slide, we have some vocab to add to your notes. Make sure that you're actually adding this vocab to your notes and not just going, yeah, Miss Bells, we'll do it. Make sure it's in there. When we come back to school, you know I'm going to do a notebook check, and it needs to have this vocab in there. So we have a linear function. Now, we've already gone over linear functions before, so you might already have this one, but just in case, a linear function, it's a line. Its graph is a line. In the past, we've seen it as y equals mx plus b. That's our slope-intercept form. Remember, m is our slope and b is our y-intercept. I'll even go ahead and label that for you guys. Slope and y-intercept. Meaning whatever number comes in front of x is the slope, whatever number comes at the end is our y-intercept. It works the same way with functions. The only thing that's different is instead of the letter y, we're using f of x for right now. We still have that constant rate of change. Remember, that's what our slope is, constant rate of change. And it's still going to be a straight line. So in our examples, we have y equals 10 minus 2x. There, remember, the number in front of x is our slope. So our slope is -2. The number by itself is our y-intercept. And in this example, f of x equals 1/4 x plus 9. 1/4 is our slope, and 9 is our y-intercept. So we're also going to be looking at two types of data, continuous and discrete. So those are the two words we're going to be writing down. Now with continuous data, this is what we've looked at for the most part up until this point with graphs. We have a line with arrows showing that it goes on forever and ever. And keep in mind that what a line is it's a series of points that are so close together that it forms a line. With these, we see there are no breaks or gaps in the line. It's continuous. And what that means is that its domain is all real numbers. It includes our whole numbers. It includes decimals. It includes fractions. It includes negatives. That's what our integers are. So continuous just means everything. Every type of number is okay. Now, the other type that we're going to be looking at is discrete data. And discrete data does have breaks. It tends to just be dots on a coordinate plane or points on a coordinate plane instead of a line. And the reason why this happens is sometimes the domain would only include whole numbers, sometimes integers, but not decimals or fractions. And you may be wondering, okay, what does any of that mean? And I'm going to get into some more detail on that. Just keep in mind that a function is continuous or discrete based on its independent variable. Now, for the most part, our discrete situations happen when we're talking about word problems. And here are some different types of situations that might be considered continuous versus discrete. Continuous things are things like time. Time is constant. It's constantly going by. And you can have fractions and decimals when it comes to time. For instance, I can do half a minute. I can do part of a second. It's continuous. Money is another thing where fractions and decimals are okay. Same with most measurements. Right now, I might be 145.3 pounds. Tomorrow, I might be 147.6 pounds. That number can have decimals. It can have fractions. That's how we know if something is continuous, is fractions and decimals are okay. Whereas on the discrete side, fractions and decimals are not okay. A lot of times this occurs when we're purchasing individual items like phones, tickets, things like that. I can't buy half a ticket. I can't buy 1/4 of a ticket. Same thing with numbers of items. I can't say that there are 3.27 students in my class. It has to be a whole number, and sometimes negatives are okay. So that's the main difference between continuous and discrete. We're going to look over these examples and see if we can figure out whether they're discrete or continuous.